Hello children, we have already seen in the last lesson what are the equations of motion and we had derived the first equation of motion. Can you please tell me what was the first equation of motion? Yes, what was it? V is equal to U plus AT. Okay, good. So, in this, what is V? Final velocity in meters per second. U is the initial velocity in meters per second. A is the acceleration that remains constant throughout the journey. That is the main condition for the equations of motion to be applicable. And T is the time. Okay, now let us go a bit further and let us find out the average velocity of the particle in this journey. Tell me, how do you define the average in mathematics or in statistics? Yes, you add all the quantities and divide by the number of quantities. Now, since there are two quantities, u and v, you add them and divide by 2. U plus v divided by 2. That is the average velocity. What does the average velocity tell you? The average velocity gives the idea of the complete journey. Throughout the journey, on an average, with what velocity the particle has traveled. That means I can say the average velocity is total displacement divided by time. Average velocity is total displacement divided by time. Now the total displacement, I will show it by s divided by t, and the average velocity is u plus v divided by 2. So I can write this as s is equal to u plus v divided by 2 into t. So this equation helps in solving some of the problems as well as it helps in deriving the other equations of motion. Okay, so just note down this, and now I will put some problems on the board and we will go through them. We will discuss them and solve them. Yeah, so let me put the first problem on the board. This is the first one. So here, take your pencil in the hand first and start reading the question carefully. Mark the important words you find in the problem and then write the data with proper symbol. Yes, so a cyclist is traveling along a straight cycling track. She accelerates from a velocity of 3 meters per second. Now keep it in mind that here the word from is very important, to a velocity of 8 meters per second in 40 seconds. Find the acceleration of the particle in the journey and distance traveled in this 40 seconds. So, let us write the data first with proper symbols. Now, the cyclist is accelerating from the velocity 3 meters per second. From means what is given to you? Yes, correct. U is given to you 3 meters per second. Now to a velocity of 8 meter per second means what is that? Final velocity. So V is equal to 8 meters per second. And what is the time for which the cyclist is traveling? It is 40 seconds. So, come to the first part of the problem. What is asked to you? Acceleration. A is equal to how much? So, A. What will be the formula that we will be using? Change of velocity divided by time. V minus U upon T. So 8 minus 3 divided by 40. 5 upon 40, that is 1 upon 8. And what will be the unit of acceleration? Meters per second square. Please don't forget to write the proper units. Second part, you want to find out the distance. Now already I have made it clear because the cyclist is traveling along the straight track. That means her distance and displacement will be the same. So what is asked to you is nothing but S is equal to how much? That is the total displacement. Now, which formula you are going to use? You have the initial velocity, you have the final velocity and the time. So, you will be using obviously S. S is equal to U plus V divided by 2 into T, or that is 3 plus 8 divided by 2 into 40. Okay, so 11 into 20, that is 220 meters. Okay with you? So please go through this and then we will come to the second problem here. Okay? Yes. So let me put the second problem on the board. Have you gone through it? Any doubt anywhere? So, yes. So let me put the second problem now. Yes, so this is the second problem. Again, take your pencil, go through each word of the problem and mark whatever you find important here. Yes, so a particle is moving in a straight line from A to B with a constant acceleration of 2 meters per second square. It moves along the same straight line now from B to C with a different acceleration. The speed of the particle at A is 2 meters per second and the speed of the particle at C is 67 meters per second. The particle takes 10 seconds to move from A to B and 15 seconds to move from B to C. Okay, that means the journey from A to C is now divided in two parts, from A to B with a constant acceleration, and from B to C with a different constant acceleration. So let us just make a rough sketch like this. Let us just make a rough sketch of this situation. So say this is the straight path. This is A here. So the particle is at A, and at A its velocity or the speed is 2 meters per second. Then from A it goes to B with a particular constant acceleration, and it is taking 10 seconds to move from A to B. So let me take the velocity or the speed at B as v meter per second, which I have to find out in part A. And then it travels from B to C with another constant acceleration, and when it reaches C, its velocity is 67 meters per second. So this total journey, I can take it as made up of two parts, from A to B with a particular constant acceleration, and then from B to C with another constant acceleration. And when the particle reaches C, its velocity is 67 meters per second. Okay, so let us come to part A here. So write the data for journey from A to B. I will consider the journey from A to B. What are things are given? Initial velocity. Velocity at A is the initial velocity of the particle. So u is 2 given to you. Okay. Then the particle is traveling from A to B with a constant acceleration of 2 meters per second square. So A is equal to 2 meters per second square given to you. Then it is taking 10 seconds. So T is equal to 10 given to you. And you have to find out the velocity of the particle when it reaches B. So which formula you are going to use? V is equal to U plus AT. U is 2, A is 2, and T is 10. So that is 22 meters per second. So when the particle reaches B, its velocity will be 22 meters per second. Now, you have to find out the acceleration of the particle as it is moving from B to C. So whatever is the final velocity at B for the journey from A to B will be the initial velocity of the particle for the journey from B to C. So for the journey from here, I will consider the journey from B to C. So for this journey, I will take the initial velocity as 22 meters per second. Then final velocity when it reaches C, the final velocity is 67 meters per second. And how much time it is taking to travel from B to C? It is taking 15 seconds to travel from B to C. Now I want to find out the acceleration during this interval. So I will use A is equal to V minus U divided by T. So 67 minus 22 divided by 15, which is how much? 67 minus 22 divided by 15, which is 3. 15, this is 45 divided by 15, so 3 meters per second square. And finally C. In C, I will consider the complete journey from A to C. But this journey is, see that for the full journey directly I can't use the SUVT equations because the acceleration is different. So first I will consider the journey from A to B. Now for journey from A to B, what will be the initial velocity? Yes, from A to B the initial velocity U is 2 meters per second. At B the velocity is 22, so V is equal to 22 meters per second, and the time T is 10 seconds. Okay, so S is equal to, I'll take this as say S1. S1 is equal to U plus V divided by 2 into T, that is 2 plus 22 divided by 2 into 10. How much it will come out to be? 2 plus 22 divided by 2 multiplied by 10, which is 120 meters. Now, I will consider the further journey from B to C. I am continuing C here. So now I will consider the journey from B to C. Now for the journey from B to C, the initial velocity. So as I already told you, whatever is the final velocity at B for the journey from A to B will become the initial velocity for the journey from B to C. So I will take U as 22, V as, what is the V for this journey from B to C? 67. V is 67 meters per second. And what is the time taken to move from B to C? Time taken to move from B to C is 15 seconds. So T is equal to 15. So I will take this displacement as S2. S2 will be U plus V divided by 2 into T. So that will be 22 plus 67 divided by 2 into 15. So how much that will come out to be? 22 plus 67 divided by 2 into 15. and that comes out to be 667.5 meters. So now I want the distance or the displacement from A to C. So that will be nothing but S1 plus S2. So 120 plus 667.5, which comes out to be 787.5 meters. So again I am repeating, directly I can't use SUVAT equation from A to journey from A to C because the accelerations are different. The main condition for applying the SUAT equations is acceleration should remain constant, and hence I am finding the displacement from A to B first because the acceleration is constant, and then from B to C and adding the two. Okay, so are the things okay with you? Yes. So please go through these problems. Yeah, and any step that is not okay with you, please clear with me. Okay, so next class we will move towards the further equations of motion and problems on that. Okay, so enjoy the day, children. Bye, see you.